Hello everyone, how are you? You can see this question. You must have seen this question in my last video also. I posted this question as a challenging question for all of you. And answer of this question is yes, you people have to tell me. But before that, let us see the question. Question is suppose that there are positive integers, positive real numbers. In fact, x, y, z, a, b, c are such that they satisfy three simultaneous equations. This is written on the screen. Then we have to find the minimum value of x square by 1 plus x, y square by 1 plus y, z square 1 plus z. So let us first solve the first two equations and let us eliminate one variable. You can see that the common variable from the first two equations is y. So I'm going to eliminate y to obtain a new equation in terms of x and z, and you can see that we have already one equation, that is third equation, in terms of x and z. So I'm going to solve the new equation and the third equation, and then we will get the value of x. So this is my approach. So I'm going to solve the first question. I'm multiplying first equation by c, and I'm multiplying the second equation by b, and I'm going to subtract these two new equations, and then after subtracting I'm getting b into c into x minus a into b into z, that is equal to c square minus a square. Now you can see there the third equation is in terms of x and z. So let us write third equation here after just below the new equation. So writing the third equation, I'm getting az plus cx is equal to b. Now multiplying this equation by b both sides, I'm getting a into b into z plus a into c b into c into x is equal to b square. Now we have two new equations, so I'm going to add these two equations to get the value of x, and you can clearly see on your screen that the value of x is equal to b square plus c square minus a square divided by 2b. See, this must be familiar to all of you. Yeah, this looks like a cosine formula for a triangle, but uh, before that, let us see. Similarly, if we solve, we can find the value of y also, and we can find the value of z also, and all these values looks very similar and exactly equal to some cosine formula, cosine value of some triangle ABC. But before that, we have to make sure that is there any triangle that exists with side length small a, small b, small c. If that is true, then we can equate x is equal to cos a, y is equal to cos b, and z equal to cos a. But before that, we have to make sure that there must be a triangle with side length a, b, and c. Okay, see here, it is given that x, y, z, a, b, c are positive, so therefore x must be greater than 0, and putting the value of x greater than 0, we are getting b square plus c square minus a square greater than 0, which means b square plus c square greater than a square. Adding 2bc both sides, we are getting b square plus c square plus 2bc. Oh, there is a mistake. Let me correct it. So we are getting b square plus c square plus 2bc greater than a square plus 2bc, which is greater than a square, which means that we are getting b plus c whole square greater than a square, which means b plus c greater than a. So this is a supporting result for existence of triangle. Similarly, if we solve y greater than 0, we should get c plus a greater than b, and similarly z greater than 0 gives a plus b greater than c. So now triangle is established. So there is a proof that there exists a triangle with side lengths small a, b, and c. Right, so now I can say that the x is equal to this is b square plus c square minus a square divided by 2bc, and which is equal to cosine of a, angle, capital angle a. Similarly y is equal to c square plus a square minus b square divided by 2ac, which is equal to cosine of angle b, and z is equal to a square plus b square minus c square divided by 2ab, which is equal to cosine of angle c. So now my expression, okay, let me rub the board. I've already done some rough work here. Okay, so you can see that if I plug these values, the values that we got here, x, y, and z, these values, if I plug these values in our inequality, in our expression, which we have to minimize, you have seen that the objective of the question is to minimize the expression x square by 1 plus x, y square by 1 plus y, z square by 1 plus z. Okay, so we have to minimize the sum of these terms. So if I put x, y, z in the place of in this expression, x square by 1 plus x plus y square 1 plus y plus z square 1 plus z, I'm getting a new expression in terms of cosine of angles a, b, c. We are getting cos square a by 1 plus cos a plus cos square b by 1 plus cos b plus cos square c divided by 1 plus cos c. So now I'm expecting this question to be little Easier because using trigonometry, there exists some standard result in trigonometry in terms of angles. We should be now feeling little bit easy compared to x, y, and z. Let us see. Uh, there is a famous inequality like arithmetic geometric inequality. There is a famous inequality, and that is called Cauchy squares inequality. And this is one of the very famous and very useful inequality which is being used these days in the advanced solving problems. Okay, so the inequality is, you should note it down, that inequality is x square by p square plus y square q square plus z square by r square greater than or equal to x plus y plus z whole square divided by p square plus q square plus r square. This is a very very useful inequality and very famous inequality, just like arithmetic geometric mean inequality as you study in the advanced syllabus. In fact, this inequality can be derived from arithmetic geometric inequality, but that is a lengthy method. So you should not focus on the proof. Rather, you should directly use the result and you should directly use this result. And let us see how we can apply this inequality in our sum. Our sum is basically cos square by a by 1 plus cos a, cos square b by 1 plus cos b, cos square c 1 plus cos a. So suppose that x is cos a, which is already yes, is the case. And you can assume that 1 plus cos a as p square. Similarly, you can assume as 1 plus cos b by q square, 1 plus cos c by r square. So applying this inequality, we are getting cos square a by 1 plus cos a plus cos square b by 1 plus cos b plus cos square c by 1 plus cos c greater than or equal to cos a plus cos b plus cos c whole square divided by, adding the denominators, we are getting 1 plus cos a plus 1 plus cos b plus 1 plus cos c. So if I just rearrange the terms to further solve it, we are getting cos a plus cos b plus cos c whole square divided by 3 plus, putting all the trigonometric terms together, we are getting cos a plus cos b plus cos c in a bracket. So in fact, this looks asymmetric. In fact, again, it is looking asymmetric. Assume that I am assuming cos a plus cos b plus cos c as a t. So we are getting what? T square divided by 3 plus t. Now, if we could get, somehow we could get the idea of t square divided by 1 plus t. Suppose that I have assumed, focus on the word I have assumed. Let's say in your mind, assume that cos a plus cos b plus cos c as a new variable t. So what you are getting is t square divided by 3 plus t. So let us suppose I am assuming a function that is f of t. Before that, can we recall this famous result from conditional identity, that cos a plus cos b plus cos c less than or equal to 3 by 2. This is a very very famous result in conditional identity. If you do not know this result, please go and find all other similar results in terms of inequality that exist for the advanced syllabus, and that is can be easily derived from the ratio and identities chapter of trigonometry. And this result in fact is very famous, cos a plus cos b plus cos c less than or equal to 3 by 2. Similarly, there is one more result in terms of sin a by 2, sin b by 2, sin c by 2, and the product of these terms less than or equal to 1 by 8. So you should go and check. Okay, so as I said, let us say f of t is equal to t square divided by 3 plus t, where t is any real number. Suppose I'm assuming in our case t is equal to cos a plus cos b plus cos c, but let's say t is any real number, and let's say, let us generalize this function. Let's say there is any general function f of t. Okay, so if I attempt to find the maxima and minima, so I am using the first derivative test. You should recall it from calculus, first derivative test, and I am differentiating the function f of t. So I am getting f test t, and rearranging the terms, I am getting f test t, that is equal to t square plus 60 divided by 3 plus t. Now you know how to apply the first derivative test. We have to find the intervals in which f test is positive and the intervals in which f test is negative. All of you know that in the interval in which f dash t is positive, the function f of t must be increasing, and the interval in which f dash t is negative, the function f of t must be decreasing, right? So I am going to apply this condition, but in our case you can see cos a plus cos b plus cos c, that is equal to t in our case, and cos a plus cos b plus cos c is less than equal to 3 by 2. So the maximum value of cos a plus cos b plus cos c can be equal to 3 by 2. Now, what can be the minimum value of cos a plus cos b plus cos c? So we cannot exactly find the minimum value of cos a plus cos b plus cos c, but we can say that is definitely greater than 0, because cos a is equal to x, cos b is equal to y, cos c is equal to z, and these terms are given as positive in our question. So sum of positive terms cannot be negative, so it must be greater than 0. So let's say f dash t is equal to 0. So after equating the f dash t equal to 0, we are getting two roots, that is minus 6 and 0. And we can easily observe that these are the trends of f dash t, that f dash t is positive from 0 to infinity, negative in minus 6 to 0, and again positive in the interval minus infinity to minus 6. But in our case, the variable t is lying between 0 and 3 by 2, which is equal to cos a plus cos b plus cos c. So in this case, our variable, according to our variable, the function f of t is increasing because f dash t is positive in the interval 0 to 3 by 2, right? So now you can observe here that yeah, I was talking about this expression here again. I just reminded all of you, I'm just highlighting these terms. So now it is not that much easy. Now the question is almost sorted, only few steps and few calculation, but there is one, you can say that a very crucial step here that you have to understand, and very crucial uh, concept of this entire solution, that is going to give you the final result, that is going to give you answer without that. But let us see that how we have to approach from now onwards, because even if we get the maximum value of the function f of t, that means that our expression is greater than equal to that function f of t according to what inequality we obtained after applying Cauchy squares inequality. Okay, so the maximum value of you can say that function f of t is f of 3 by 2, because as it is increasing in the interval 0 to 3 by 2, so it must be maximum at the t equal to 3 by 2. So maximum value of f of x is equal to f of t is equal to f of 3 by 2, and oh, there is a mistake, it should be 3 by 2 whole square divided by 3 plus 3 by 2, it should be 3 plus 3 by 2, right? So okay, this is a simple calculation, and we are getting 9 by 4 divided by 9 by 2, which is equal to 1 by 2. So the maximum value of f of t is equal to 1 by 2, and minimum value, obviously it must be obtained at t equal to 0. So in our case, whenever the variable t lies between 0 to 3 by 2, the function f of 2 lies between f of 0 to f of 3 by 2. And you can learn it, you can directly recall it from the definition of increasing function, that if the function f of x is increasing, and suppose there are three variables x1, x2, x3, such that x1 less than x2 less than x3, then this is very obvious from the increasing function that f of x1 less than f of x2 less than f of x3. I am going to apply that concept here. So see here, the master stroke that I was talking about is, since cos square a by 1 plus cos a plus cos square b by 1 plus cos b plus cos square c by 1 plus cos c greater than equal to f of cos a plus cos b plus cos c, which we have seen just earlier, and yes, now see, the expression on the left hand side has to exceed the all possible values of the expression on the right hand side, right? Whatever be the value of cos a plus cos b plus cos c between 0 to 3 by 2, whatever the combination of cos a and cos b and cos c exists, for every combination of cos a and cos b and cos c, we know that cos a plus cos b plus cos c lies between 0 to 3 by 2. And for every combination, for every possible value of cos a plus cos b plus cos c, we have to find the values in such a way that the expression on the left hand side, that is cos square a by 1 plus cos a, cos square b by 1 plus cos b, cos square c by 1 plus cos c, must be greater than or equal to the expression on the right hand side, which is f of cos a plus cos b plus cos c. I think that it should be clear to all of you. Yes, this whatever is being written on your screen, I already explained this. I have applied the concept of increasing function, and I have shown that the value of f of cos a plus cos b plus cos c lies between 0 to 3 by 2, for the value of cos a plus cos b plus cos c lies between the value of f of cos a plus cos b plus cos c lies between 0 to 1 by 2. So since this again, yes, whatever I explained, I'm just going to write it again. Since the expression on the left hand side, that is cos square a by 1 plus cos a plus cos square b by 1 plus cos b plus cos square c by 1 plus cos c greater than equal to expression on the right hand side, which is f of cos a plus cos b plus cos c, which means what? Which means that the expression on the left hand side has to exceed the every possible value of the expression on the right hand side, and we know that the every possible value of the expression on the right hand side lies between 0 and 1 by 2, as you can see in the yellow line. I have just proved all possible values of f of cos a plus cos b plus cos c. Okay, So now what follows, what you can derive? Okay, there is just typing mistake, please correct it. It should be cos a plus cos b plus cos a. Okay, it's just a typing error, please correct it. I've already recorded this video, I'm just giving the voice right now, so I cannot edit this video. Please correct it. Okay, so what do you think? I think that if the expression on the left hand side exceeds, or you can say that crosses, if the maximum value of the expression on the right hand side, then it naturally crosses or it naturally exceeds all the other values of the expression on the right hand side. Suppose that if the expression on the left hand side crosses 1 by 2 or exceeds 1 by 2, which is the maximum value of the expression on the right hand side, then expression on the left hand side automatically exceeds all other values of the expression on the right hand side. So therefore the minimum value, that is, what do you think, the minimum value of the expression on the left hand side should be equal to the maximum value of the expression on the right hand side, so that the expression on the left hand side exceeds all possible values of the expression on the right hand side, and therefore minimum value of the our expression on the left hand side, which was equal to x square by 1 plus x plus y square by 1 plus y plus z square by 1 plus z, is equal to 1 by 2. And this is really fantastic result, a fantastic solution. I think you people, all of you, should try it once by yourself after watching this solution, because this video involves too many concepts